All right, so I wanted to give you guys a video of something else that you can kind of see, like a different kind of problem, similar to example 4, but a little different. So we're going to look at 24 from the homework set. All right, so we got a coal mine, and their daily output after T hours of working is approximately that equation in tons. And so they're only working for 12 hours a day, only working 12 hours a day. And we want to find what is their maximum rate of output. Okay. So the thing to really watch out for here is that we're looking for the maximum of the rate. So we have to find the rate, and then we have to maximize that rate function. And then again, here it's a little nicer because the endpoints are a little easier to see, because it specifically gives you the domain. So the ends of the domain are just going to be when t is 0 and t is 12. When are they more productive? That's what we're trying to figure out here. When is the productivity the highest? What's the maximum rate of output in a 12-hour shift, given this model? All right, so we need to, let's call this f of t. We need to find f prime of t to start. Take the derivative, that'll be 40 plus 2t. Then the 3 comes down, that'll become minus 1/5 t squared. We want to find the maximum value of that. So the maximum rate of output is going to be when the derivative of this equals 0 or is undefined, or at the endpoints. Those are going to be our candidates. All right. So let's take the derivative again, because we're going to eventually want to set this equal to 0. And that'll be 2 minus 2/5 t. Critical point, when that's equal to 0. Critical point of f prime, right? So we'll solve this equation. This is a nice little linear equation. Add 2/5 t to both sides and multiply both sides by 5/2. You get that t is equal to 5. So this is an option. So this will be one candidate. So what is the rate of output when t is equal to 5? And again, we're maximizing the rate. So this is our objective function. So f prime of 5 is going to equal, when we plug in 5 there, all right, 40 plus 2 times 5 minus 1/5 times 5 squared is going to give us 45. So after 5 hours into the shift, the rate of output for these miners is 45 tons of coal per hour. All right, and that's one option, but we always have to check the endpoints. Here, there's only one critical point. There are multiple critical points. We check multiple critical points. But there's only one critical point here. So let's also check the endpoints. So t equals 0 and t equals 12. We'll plug those in as well. So if you plug in 0, what is our rate? How fast? What's our productivity at the very start of the shift when t equals 0? So if you plug in 0 here, you're just going to get 40 plus 0 minus 0. So at the start of the shift, it's 40 tons per hour. That's option 2. So 5 hours into the shift, they're doing 45 tons per hour. At the start, they're doing 40 tons per hour. So option 1 is the winner so far. And then at 12, we plug in 12 into this function. And I will plug in 12 real quick. So I don't remember the function. Minus 2 times 12. So 40 plus 2 times 12. Minus 1/5 times 12 squared. At the very end of this, oof. At the very end of the shift, 35.2. This makes sense. Right? it makes sense that they are not as productive after 12 hours of working, right? I am the same. Although I'm going to be honest, the difference in my productivity between the beginning of my shift and the end of my shift is way bigger than the difference here. So we just pick the biggest one. We want to know the maximum rate. So we have 3 options and we pick the biggest one. 40, 35.2, and 45. That 45 is the biggest, all right? So it's going to be 5 hours into the shift. Is our max productivity, and that is 45 tons of coal per hour is our answer. So find your critical points, look at the value at the end points, and just pick the biggest one or the smallest one, depends. All right. So good luck with the homework problem. Good luck with the exam. Please let me know if you have questions on the review sheet as well. And have a great day.